Good morning everybody! In this video, I will walk through some basic features and usability of Phometa. Well, let's start. Once the program is open in the web browser, you will see the welcome page alongside with the key map pane, which show every possible keyboard shortcut on the current state of the program. Alternatively, you can click each row directly. Phometa also has a navigation bar which exposes the global structure of proof repository, which in turn consists of packages and modules. At the beginning, Phometa consists of three built-in formal systems, which is propositional logic, simple arithmetic, and type lambda calculus. For propositional logic, if we look it closely, you will see that it consists of list of nodes, which can be either comment, grammar, rules, or theorem. And now we want to prove the first theorem as the same as this. We want to prove that P and Q hold under an assumption that P and P implies Q hold, which is a valid judgment. This can be proven by click the top level propositional logic first and click add theorem, and then I'm gonna write the name of the theorem that I want to use. And now we get a blank theorem, so we can specify go by click choose grammar, click judgment, and now judgment split into context and prompt. For the context, because we want to assumption, so we split context twice before terminate it with epsilon. For the first assumption, it is P, but we can't just write P directly because now it is prompt. So we need to state that it is atom first, and then we type P and hit enter, and then we get the first assumption. For the second one, it is P implies Q, so we can click implies atoms P atom, and then we type Q, enter. For the conclusion, it is similar as well, so I'm gonna click as it should be, and then we finished inputting the goal. So now we can prove the theorem using rules. But in order to make it more clearer, I will split the screen into two subplanes like this. So now you can see both of ongoing proof and the rule that I want to use. So now we want to prove this theorem using an introduction. So we can do this by proof by rule, and rules will appear here. This is the rule that we can use. For the complete list of rules, you can see this. Alternatively, we can click proof by rule and type the name to filter it. And intro. Once one choice is left, we can click return as well for convenience. Now the main goals is fulfilled and generate two further sub goals. For the first one, you can see that its conclusion P is already in assumption, so we can use hypothesis rule. For the second one, we would need imply elimination. So imply elimination look like this. So we're gonna apply it, but it doesn't generate a further subgoal automatically. This is because this rule has parameters a, which is belong in premises but not in conclusion. So we need to state it first. So pattern matching and substitution can work properly. So I'm gonna use P for A. So now you can see that both of conclusion is inside assumption. So we just apply hypothesis twice, and then we finish this theorem. Moreover, you can log the finished theorem to make it become a lemma. The lemma is a theorem that you can use for later proof. And before we go further, I just want to explain more about hypothesis. This is not ordinary rule because it can penetrate through assumptions, right? So what does it look like? Well, it looks like this, and because it's called hypothesis based as well, I'm gonna show hypothesis based as well. Hypothesis based is a rule that proves the judgment that has conclusion the same as its last assumption, and it doesn't generate further subgoals. So the thing is, hypothesis will try to call hypothesis based first. If it is success, the entire operation success. But if it is not, it will cascade down and call itself again, but cutting the last assumption out. And then it will call hypothesis based again and again until it finds the right assumption. But if it can't find anything, so it will write an error message state that this rule is not applicable in here, but with exception not subset like this. Okay, the next thing that we want to do is we want to prove the second theorem, but now we want to prove prop, not judgment. A prop will be valid prop if it is a tautology, as we will show here. So I will click propositional logic and add theorem the same as the last one. Demo theorem 2. And now I'm gonna input the goal that we want to use. So this one gonna be R implies P atom Q the same, and then I write P. But you can see now I try to write Q, but it doesn't belong here, so exception writes as it should be. So I need to state to be atom first, so I can write Q here. But wait a second, I intentionally make this theorem wrong, so I can show that we can edit the goal. So if you click the one that we do it wrong, so it is this one, you can reset the term by click alternative T or click this one directly. So this one will reset the subtree that we want. But this one is not right as well because we want to reset prop, not atom. So we can click up arrow to go top level. So now it is prop, but it's wait for atom. So we can click reset current term again. So now it is a prop, right? So we can write the correct one, which is atom Q atom P. And now we get goal. So how can we prove this? Well, we have a special rule for proposition which called prop intro. It states that we can prove that a prop is valid if it's hold under no assumption. So I'm gonna use it, and now we can prove it as normal. And then you might see that well, we can use law of exclusive middle, right? Because if P is true, then this one is true. If P is false, then this one is true. But to use that, we need to apply or elimination first because it is backward reasoning. So what is or elimination? It looks like this. So is gonna be the same. So I'm gonna write or elimination. And then specify parameters that we need. This time it is P and not P. So we can use law of exclusive medium. But do we need to prove law of exclusive medium by ourselves? Well, no, because we have a nice lemma. I mean, we have a built-in law of exclusive middle already, which has been proved this already. So we just click proof by lemma and use it directly. And this one can be used because the meta variable here can be specialized to be P. Okay, now the thing become too clumsy, so I gonna make this thing become full screen again. So jump to menu and become full screen. Second one. Okay, this one because P, it has assumption P, right? So this one should be true. So I gonna use or into right. And now we can use imply intro and hypothesis. For this one, similarly, I'm gonna use all into left, and then implies again, and then we want to use bottom elimination. And then we want to use not elimination again. So in this time, because it is not elimination, right? So it is A or not A. Yeah, A not A. So this one should be P. So we write P, and then both of them can be proven using hypothesis again. And this rule is finished. So now you might think that, oh, this is a long proof, and how can we read it nicely? Well, Phometa has a nice feature about focus and unfocus the rule. Oh no, sorry, theorem. You can see that we have a focus button here. If we click this one, you can see that the entire thing is folded out. Left just the rule that we want to see, and the thing it for, which is its sub goals. We can focus it further. This one will unfocus the last one and focus this one. Or alternatively, we can click unfocus, which will unfocus everything, and the rule will, no, the theorem will become the same again. So now I would like to introduce a new thing, which is equivalences. You can see that the propositional logic here so far support judgment and props as tautologies. So how can we use equivalences? Well, we can't do it at the moment, but we can add it manually. And I'm gonna show it how to do this. So if we click add grammar, and then I write equivalences, which is just a name, EQUVILENCE. Well, I think I make a mistake, so yeah. So enter. Now we get a draft gamma, and equivalence should have just one alternative, which consists of two propositions. So I can add choice with two subterms. Then specify this as a prop. This one as well. And equivalence will have operator, which is similar to equal, right? So I'm gonna write it. But wait a second, this one is Unicode. So how can we write this? Well, Phometa also has a feature about Unicode as well. If we click search Unicode, then you can select what Unicode that we want, and the name is correspond to LaTeX. So this one should be EQU, and you can see that it's come up here, so I can click it, and then we get the Unicode that we want, and then we click enter. So now the grammar is finished, so we can lock it. Now we can use it, and so far the equivalence is just syntax. We need a rule to prove it, so I'm gonna call it EQU intro, which is equivalence introduction. So and I would like to state that we can prove that for A equivalence to B, this can be proven by two premises, which is judgment. We can prove under assumption of A and vice versa. And this rule is finished, so we can lock it for further use. Okay, as shown here, so I'm gonna close this. So I'm gonna show a very basic proof of equivalence. So we can try to add a theorem, and I'm gonna call it demo theorem 3. In this one, I'm gonna show about and cumulative. So we want to prove equivalence. A and B is equivalent to B and A, and we can use the rule that we just introduced here. And now to prove this one, it just become the matter of fact to prove judgment, which we are familiar about so far. So I'm gonna leave it at exercise. Then we come to the last part of the demonstration, which is about meta reduction. So as you can see that for the context, right? The context is in fact a set, but we implement it as a list. So this means we should be able to duplicate assumption or permute assumption freely. So how can we achieve this? We can achieve by using context cumulative, which state that for the context that followed by A and B is the same as the context followed by B and A. And this one this rule also have a flag said that allow reduction. This means that we can reduce the term, the context term implicitly. Yeah, the same as idempotent, which is just compact it out, and idempotent to which expand out. So to demonstrate this, I'm gonna add another theorem. So I'm gonna call it demo theorem 4, and maybe I can call judgment, and we have loss of assumption. We just say C, D, C, and maybe C. So this rule, this theorem is clearly provable using hypothesis. But the whole point of this is I would like to illustrate that the meta reduction works. So if we click here, this subterm, you can see that it has some rules that we stated before. Because this rule has allow reduction flag, so we can use it to reduce. So if I click context cumulative here, you can see that C and D is swapped. And what if we click here, we can reduce the duplication as well. So that is the end of the demonstration. I hope that this demonstration can make audience understand Phometa better. Thank you so much.